Troubleshooting. Troubleshooting this system. We're going to start with the input piping and its components. Go over each one of the components and then tie it together with some tips on troubleshooting. Here we're looking at the piping as a whole. Piping consists of three sections: input piping, bypass piping, and output piping. So what we're going to do is take a look at the input piping first, which starts right here with this PVC ball valve. And that is the input deionized water that comes into the system. The next item is a flow meter. Hard to see it, but it is right there. It's a flow meter. Macmillan is the type or the manufacturer. Then we come to a T here, and we've got a air vent. This vents out any excess air that may come into the system. It's not going to vent it all out, but it's going to vent out big chunks of it. Then next down here we've got a solenoid valve. This is the input solenoid valve, which opens and closes when the system is calling for humidification. Then we go down here, we've got a T that comes off the regulator. We'll talk about that later because that gets into the bypass piping. Got a union for disconnecting and unconnecting some stuff. Right down here, just above the pump, we'll see another picture of it later on. We've got a filter, a 10 micron filter that actually catches any, it filters the water if anything comes in. Right here we've got a pressure transmitter that tells what the incoming pressure is. And then after that, behind here, we've got a gauge, a input pressure gauge. Here's a picture at another angle where you can see the gauge. Now you can't see the transmitter. Filters down here. And you can't see the solenoid because it's behind some things, but picture at a different angle. Here's another picture at a different angle. You can see the filter a little bit better. And then a few things you can't see. You can see the flow meter a little better. Gauge, transmitter you can't see as well. And one more picture before we get into some descriptions of operation. A little bit better close-up picture of the filter, transmitter, gauge. Again, this is input piping, low pressure piping. Okay, so many of these systems that are installed have water regulators that regulate the incoming water pressure. This particular line here comes into the shutoff valve. Typically it's regulated around 30 psi, maybe 35 or 40 psi. And all that does is prevent fluctuation and maybe a large or small, just prevents fluctuation, let's just say. And I like it. The pump itself here has a rating of 60 psi on the inlet. And sometimes you get water pressures that are greater than that. But typically the water pressure is 60 to 70, 80 psi. I recommend a regulator just to keep it below that recommended 60 psi. Also, the other thing is if you do get a leak on the input water pressure side, you don't have water spraying around as much at 20 or 30 or 35 psi than you do at 60, 70, 80 psi. So that's another reason. Now this input water piping is a loop. You can see it comes in here, goes down here, goes around, and then comes around and goes into the bottom of the pump. That is the input side of the pump. Now one other item I forgot to mention is on the opposite side of this particular piece of pipe here, there's a pipe going over the other side, there's a temperature sensor that actually senses the temperature of the water. Now that's actually on the bypass loop, which we will discuss here. This is the bypass loop. We'll discuss that a little later. But I just wanted to tell you that there's one other item that's on the input side and also on the bypass side. All right, so we have this loop that loops around, goes into the input. And to design a system like this properly, the temperature or the pressure transducer, again, which is behind here, you can't quite see it, and the gauge that monitors the pressure coming into the pump are the last things before it goes into the pump. And the reason for that is kind of self-explanatory when you think about it, is that if we have anything that happens with this filter clogs, solenoid doesn't work, flow meter stops for some reason, or somebody shuts off this ball valve, and or somebody shuts off the water supply a little higher up within the stream, this pressure transducer senses it and shuts the pump down. Here's a little bit of picture of that pressure transmitter. At this point, I'm going to point out that you see within the system a lot of flexible braided hoses, stainless steel braided hoses, and that's to eliminate vibration. The pump itself is a positive displacement pump that does a lot of pulsing, and in order to not have that pulsation transmit to the rest of the piping, we use flexible hosing. All right, back to this pressure transmitter. This is a transmitter that transmits 0 to 10 volts DC depending on the water pressure that's in the pipe. I believe the range of this particular transmitter is like from 0 psi to 200 psi. Now I could have used a smaller transducer, smaller pressure, because we only really have 30 psi coming into it. But I wanted to use something a little bit higher in case there was any back pressure that eventually got back into the system from the discharge or the high pressure side to prevent, I used a larger pressure transducer to prevent damage to that transducer. If you had a transducer that was maybe only rated for 60 psi and somehow high pressure got back from the high pressure side of the pump, it would damage this transducer. Having the range from 0 to 200 psi, it actually has a maximum pressure coming back to it at 400 psi. So it's rated a little higher, and that's why I chose it. So if we're at 30 psi with this transmitter here, that means it's putting out about 1.5 volts. So that voltage goes up to the Allen Bradley controller, a Micrologic 1100 controller, and it monitors that voltage. And then there is an alarm threshold of 10 psi. So if this transmitter ever goes down to 1/2 volt, which would equal 10 psi, the system would go into alarm and it would shut down. And it does shut down for good, meaning it will not restart unless someone comes and pushes a button to restart the system. Now this setting of 10 psi as far as a low threshold for alarm can be changed within the settings on the display, but that's typically where it's set. It might be set at 15 psi, 10 psi, right around that area. So the whole reason behind this is that we do not want to prevent water flow to this pump. Again, better picture. We do not want to prevent water flow to this pump. As I've stated earlier in other videos, I'll state it again. This is a water lubricated pump by Danfoss. If you eliminate water going into it and the pump is still running, it will damage the pump. So that's why we need some sort of pressure sensor on the incoming line, and if we lose pressure, the pump will shut down. And again, that is why this pressure transmitter, again, which is behind here, is where it is. It's one of the last things within the loop. You've got things in here that could prevent flow. Again, the filter, water solenoid valve, flow meter, shut-off valve. Any of those malfunction or anybody turns any of those or something happens, it will sense no flow to or no water pressure to the pump and shut the system down. And again, it shuts it down and it has to be manually reset through a push button or a touch screen display. And here is the display. Over here on the left are the 4 alarms that the unit has, one of them being a low input water pressure alarm. I do believe it's this third one. We will zoom in here shortly to see which one it is, and I'll describe it a little more. All right, here we are zoomed in, and we cannot see all the words here due to the Microsoft bar, the bar covering up some of these words here. But it is this one here, input water pressure alarm. Right now it says false right there. You can barely see it, but then it'll say true. It'll turn red, and that indicates that the unit is shut down if it goes into alarm. In order to restart it and to see whether it will run again after you've potentially fixed the problem, you push this reset button with your finger, or you push this red reset button down here. Both of those buttons will do the same thing. This one, however, will light up. It is red in color, and it's not lit. It's not lit up now, but it will be colored in red. As soon as you push it, the red light will go out, and the unit will try to restart. That restart does take a while because there are built-in time delays with this unit. It could be a couple of seconds. It could be up to 30 seconds before it restarts. Here I'm going to zoom in on the alarm settings itself, and this is the one that we are talking about. Alarm setting, low input. Set point is 15 psi, so this unit will shut the pump down at 15 psi. There is a time delay that is built into that setting. So if it goes to 15 psi, it won't shut off right away. It will take 3 seconds, and then it'll shut down. And as it's counting down, this countdown timer will light up and count 1, 2, and as soon as it gets to 3, the system will shut down. You can change the alarm values of these. You can push this button here on the display. It'll ask for a password, and you can change the set point. The same as with the countdown second. You can push that on the display, enter the password, and then you can change its value. And that is true with all these other alarm set points that we have here. All right, we're going to conclude on this input piping portion of this video by talking about what are the most common causes of low input water pressure. Well, the first one would be the incoming water supply from the facility. That's probably going to be the most common one that would cause that alarm to happen. And then the next one would be the solenoid failing or the filter clogging. So now the solenoid failing, that solenoid is powered by 24 volts AC. And here is the line right here, this white cable here. And here's a little better picture of it. Here's the input water solenoid itself. It is a 1/4 inch valve, not real big, and it really doesn't have to be big because the flow out of these pumps is not large. This valve is probably rated for, I think it's 3 or 4 GPM at a particular pressure drop, certainly enough. So, and it has the coil back here. That coil is 24 volts AC, and here is the cover to come into the coil, the power to come into it. As you can see, we're using just this white wire here, multiple. There's 3 wires in there that go to the coil. One's ground and 2 are the hot. Being 24 volts AC, we do not have to run it in conduit, so that's why we're just using this small wire. All the solenoids in this system are 24 volts AC, so you'll see more of those white wires that power the solenoids. That solenoid goes up to a terminal strip where all the input and output wiring go in, and from there you could check voltage going out to the solenoid. And we'll show a picture of that terminal strip here shortly, but as long as I'm on this picture, I'm going to talk about this flow meter a little bit. Now, this flow meter could restrict the flow if the turbine within it got stuck. That would restrict it enough. Some water would still go through, but it would restrict it enough, probably to cause a low pressure shutdown. This flow meter has 4 wires going into it. 2 of them are 24 volts DC to power the electronics within this flow meter, and the other 2 are the DC signal going out. This meter is actually 0 to 5 volts full scale. It is not like this pressure transducer down here, which is 0 to 10 volts. This flow meter happens to be 0 to 5 volts. And then there's the filter itself. This filter has a screw-on bowl, and it actually has 2 filter elements in it overlapping each other. The first one being a 50 micron screen stainless steel, and the other one that overlaps that is a 10 micron screen stainless steel. So that would catch any particles that are coming into the system. The pump itself, the requirement for it is 10 micron worth of filtering. So that's why this filter is on there. Now the big question you might ask yourself is, this is deionized water coming into here. Why do we need a filter? Well, first of all, Danfoss requires a filter on them, that's in their specifications. And secondly, we have bypass water. High pressure water comes out of here, goes into this solenoid valve, and here's a line right here that goes out to the high pressure side. This is a bypass line that actually goes around, goes through a pressure regulator, and then it comes back through this tube right here, back into the input side of the pump. So the whole idea behind this filter is, as you accumulate hours and hours and hours of runtime off this pump, you start to get fine particles of debris from wear, because it is, it's a pump and it's running. You can get fine particles of debris that'll eventually wear off of that pump, and they'll come back and they'll get caught in this filter. Then they will not return to the pump itself. That is the main reason behind this filter, is to improve the life expectancy of this particular pump. Now we'll go over that bypass circuit a little bit more later on in this video, but I wanted to at least talk about the filter, why it's there, and introduce the bypass circuit. And the last thing we're going to look at here is the terminal strip, where power goes to the components for the input piping section. Now I'm not going to get real specific here, because what you should really do is look at the electrical wiring diagram to determine which components or which terminals here go to the input components itself. But just to give you an overview of this, right here, this is the sensor section. This is where the water sensor or the flow meter will come in to give its 0 to 5 volt signal. And this is all where the 0 to 10 volts signal will come in for the input water transmitter that monitors the water pressure. Also here is going to be the output pressure sensor and other sensors. So this is the sensor input block. These are fuses here for the solenoids themselves. We actually have the input water solenoid, and then we have the solenoids for the output to the different zones of the system. So that's what this is for. And then these other devices or these other terminal blocks are input powering, output powering for solenoids, etc., DC and AC power. And then you have the grounding terminal block, and then you have a receptacle block here to power some power supplies. These sensor wires from the input pressure sensor and the flow meter, they actually go up and they go into this Allen Bradley controller up here to monitor those pressures and take action on when they go into alarm set points. So that's it. That concludes the input piping troubleshooting and inspection. So on to output piping and bypass piping.